In question 4, we are given the regression analysis result in an ANOVA table, and we want to determine as a first question the hypothesis testing. All right. So the hypothesis testing is always H0 B1 equals to B2 equals to all the way to BK equals 0. This means there is no linear relationship. All right. And H1, it can be at least one of the BJ's, it can be different than 0, and J can be one of the variables from 1 to K. And this means there is a linear relationship. And for this case, we need to determine what the K, all right? So how many beta 1, beta 2, beta so forth do we have? And the variable that we look for is this number here, and that's representing K. So that's how many variables you have. And therefore H0 will be beta 1 equals to beta 2 equals 0. And H1 will be at least one of the BJ's different than 0. And J, it can be either 1 or 2. All right, so let's input it. Here we have this selection. So the first one should be okay. And for the second one, at least one of the BJ's, it can be different than 0. All right. Okay. Now we are looking for the test statistic, and the test statistic is the value F right here. So this is what we call F stat, and we can read it right away from here. So this is 49.6312. Check it. Okay. And right now we are looking for the p-value. So for the p-value, you can really read it right away here. This is the p-value. It's already output on Excel. However, it's telling you it's less than 0.0001, and that's basically 0, right? There is another way to do it, and that by using the formula in Excel. So you can use equal sign, and then we're going to use the F distribution. So F dot distribution, and we're going to select the second one, the one that has RT, it means right tail. And then we're going to input the value of the X, the F statistics, and that's going to be 49.6312, comma, we're going to input the degree of freedom, and the degree of freedom, they are right here. So the K, we start with the K, which is 2, and the N minus K minus 1, that's 98. So we're going to input here, go back to the formula, 2 comma 98, and close the parentheses. That's all. And this is going to give you, well, we see 1.2 e to the minus 15. That's technically is 0. All right. So here you can turn it into a number if you want to see what's it going to be. So select the cell and put numbers, and that's 0, right? And you can see here 0.00, so it's 0. All right, let's turn it back, plug it in. So here they want 3 decimal places, 0.000, should be fine, and check. All right, so in this question we want to figure out whether we can accept or reject the null hypothesis. So it is easier since we get the p-value equals to 0.00. We know what is it. Is it easier to evaluate it or to compare it with the level of significance, which is 0.1 here, level of significance is given to you. So let me try to explain what's going on. So first of all, we know that the alpha it's going to be 0.1. So let's assume this is my alpha. The alpha is always a probability, so is an area, alpha value. The point that ends with the alpha value here, that's going to be called the critical value, or we can call it as well F alpha. All right. Now, this critical value is going to divide by chart in two parts. The side from the alpha side is going to be the rejection zone. So here where we're going to reject A0. And the other side is going to be do not reject, of course, A0. So we don't know really the value of the critical value. All right, we could find it, but they didn't ask us for it. So we are not going to compare the F critical with the F statistic. And here, this value that we get here so far is only the F stat. So I don't have the F critical or F alpha. So what I'm going to do then, obviously I cannot use this property over here. I cannot compare the F stat with the F alpha. So an alternative formula to this is to compare the p values and the alpha value. So the p value, if it is less than the alpha, here it's going to be reject 80. So it is very similar to this statement. So what is the p value? So we understand the alpha value is where the F critical stop. Now the p value, since we get it is equal to 0, so it's very small tail, right? So we can barely see it. And let's say this is the tail of the p value. So this is a p value, all right? So the point where the p value stop, very similarly here, it can be called the F stat. And we know this is F stat is going to be 46 point something, right? Around 46. So now, obviously, because p value is smaller, the F stat is greater than F alpha. So we can reject. In other words, we just have to verify whether the p value, which is 0.000, all right, is less than 0.1, and that's our level of significance. All right. Is it true statement or false? This is true. So every time you get this statement true in here, you are then rejecting 80. I hope this is clear. So your conclusion, you are rejecting 80 because the p value is smaller than the alpha. And that's the statement that I'm supposed to look for it. So I'm rejecting 80. And yeah, I forget to mention one more statement. Every time you reject 80, this implies you have evidence. All right, you have enough evidence to reject. So this is always true. If you do not reject, you don't have sufficient evidence to reject. So our statement would be obviously to reject. So either C or D. And do we have sufficient evidence or not? We do, yes. So you're going to be C instead of D.